All right, guys, we just completed this section on make.com about what LLMs are, large language models. They're neural networks. Specifically, I think they're referred to as transformers, which are neural networks that process text and generate text. There's three layers to the neural network. There's the input, then there's something in the middle, the hidden, and then there's the output. So the input nodes, hidden nodes, and then the output nodes, something along those lines. Each node processes the previous data and further processes it and then passes it on to the next node. So a lot of neural network models, what they're doing is they're converting whatever their input data is, and they're converting it into numbers. They're converting it into numbers that can be mathematical operations can be done on. And that's what the processing is. It's converting it into numbers and then processing it mathematically. I think that's pretty awesome. I didn't know that's how they worked. It's really cool. So LLMs, here's the little understanding that I have as of right now. So an LLM will break down text into tokens, which are units of text. They can be words, they can be phrases, or groupings of words, or they can be smaller than words, like sections of words, subsections of words, subgroups of words, and even individual characters. And so first the LLM will break down the text into tokens, and then it will assign IDs to each of the tokens. So these IDs are based on the vocabulary that the LLM has, which it gains in its training phase. And so each token should have an ID. If it's not in the vocabulary, then it's going to have to do some other operations, maybe break it down further until it does find its vocabulary, or maybe mark it as unknown. So it breaks into tokens, identifies them all, gives them IDs, and then it basically translates these IDs into vectors, right? And these are vectors in multi-dimensional space, not one or two or three space. We're talking, make.com said 512 space, which was chosen to balance deep contextualization, but not so much that the trade-off is computation power needed. So the idea is that the better and more computational power computers we get, like quantum computers, we can build even more complex embeddings, is what they're called, converting these IDs, token IDs, into vectors. And so it does this, and then it processes the data in this way, maybe using context to further process it. And then at the end, it uses this information to predict the next most likely token and onwards. And so, yeah, that's the idea behind it. It's converting it into numbers and then doing mathematical operations on it. And I think I'm self-learning linear algebra right now, and I'm thinking my prediction is that these are referred to as general vector spaces, these multi-dimensional vector spaces, and Euclidean vector spaces rather are 2- and 3-dimensional vectors. That's my idea as of now. Each dimension of the vector, the 512 different dimensions, is like a different aspect or property of the word or token, such as lots of things. They used examples of like foods. Like one dimension could be like its vegetableness, one dimension could be its dessertness, one could be its like color, or like its redness, its greenness, its blueness, its crunchiness, its density, things like this. There are different characteristics of them. Words will have, or tokens will have 512 of these in the standard LLMs, I guess. And the one other thing is that I learned about there's first you're going to typically train LLMs on using unsupervised learning. This is called like the training phase. No, they're both called the training phase. This is called something, the learning phase or something, and then there's the fine-tuning phase where they use supervised learning in order to fine-tune and give it like a specialty, whatever that may be. For example, one example would be assessing sentiment of the statement. So, all right, that's the section on LLMs. Like we got a brief overview, a little better understanding of LLMs now. We just started a new unit, the next unit on how to interact with LLMs, and this is all in the AI Introduction to AI course on make.com. All right, that's it for today. Talk to you later.